This module shows how import can be used to extend the features of Python to include tools required for data analysis. It also introduces methods to shorten the names using as well as a set of canonical names for the core set of modules used in data analysis. Finally, we'll see how specific functions can be imported using from. Start by opening the Lesson 3 notebook and importing it. Then run a couple cells so that we can see the problem in the notebook viewer. Python does not come with the complete set of tools required to work with numerical data. Instead, these are provided by a number of useful modules. The key modules are Numpy, which provides the base array class that allows for data to be stored efficiently. Pandas, a library for working with data that features many methods to import and export data and a useful way to access data by names. SciPy provides a set of algorithms that are used with NumPy arrays. For example, it contains numerical methods to minimize functions when we don't actually know the solution. It also contains methods to integrate functions using numerical methods such as quadrature. The most important component from SciPy is the stats module, which provides a number of methods for interacting with random variables, such as computing CDFs and PDFs or inverting the CDF. Matplotlib provides a complete graphics solution. In particular, it applies a number of high-level functions that can be used to visualize data using methods such as line plots, histograms, and scatter plots. Finally, Stats Models provides a number of statistical models such as OLS for cross-sectional data or ARMA for time series data. Most of the important components of Stats Models are imported using Stats Models API or Stats Models TSA API for the time series routines. Modules are imported using the keyword import followed by the module name. This allows modules to be imported either with their high-level name, such as import NumPy or import SciPy, or for submodules to be directly imported using, for example, import scipy.stats. Here, I import the core set of modules, NumPy, Pandas, SciPy, the stats modules from SciPy, Matplotlib PyPlot, which contains the most useful plotting functions, and Stats Models API and statsmodels.tsa API. Now that NumPy has been imported, I can use numpy.array to construct an array containing 3 values, 1, 1, 1 in this case. We'll see NumPy array in a later lesson. If I run this cell by pressing Ctrl-Enter, we can see the output in the right side. Importing NumPy has made NumPy available to the program, which includes all functions and submodules that are contained inside NumPy. This includes functions like array, and it also includes submodules like NumPy linalg, which contains a number of important routines from numerical linear algebra. You can see all of the functions that are contained in NumPy linalg. Each of the lines that has a purple symbol is a different function. While modules can be imported and used with their full module name, it's most common to use the keyword as to assign a shortcut to each module name. Here we use the reserved keyword as to import modules using their canonical name. We can import each of the modules using their canonical format. For example, starting with NumPy, we import NumPy as MP, we import Pandas as PD, we import SciPy stats as stats, import SciPy as SP, import matplotlib.pyplot as PLT, import statsmodels.api as SM, and finally import statsmodels.tsa.api as TSA. This set of imports here all use the canonical names. These are important in practice because it's common to find examples on the internet that all refer exclusively to these canonical names, and so you're expected to be familiar with them. If I run this cell, we don't see any output, although it has imported these modules again and assigned them to their shortcut names. This allows me to use the shortcut name in place of the full module name. For example, I can type np array 111 and produce the same output as I had before when I used the full module name Numpy. It's good practice to use the shortcut names to help keep your code tidy. It's also important because in some cases, full modules can be very long. For example, SciPy contains a module called regression, which in turn contains a submodule called linear model. This module finally contains OLS, so it is possible to import this full module and then use the full name, although this makes for code that is extremely difficult to read. If I run this cell, I can then use the full function name and type dot and see with IntelliSense the functions are available, and there is OLS. Fortunately, statsmodels.api also provides OLS, and so if I type sm.ols, I will get the exact same thing as if I imported it from the full module name. This final problem demonstrates an alternative method to import specific functions from modules using a different syntax. Here we use from module import function. Using this syntax, we can use from Numpy, import array, square root, log, and exponential using a comma-separated list. I can also do from stats models, regression, linear model, import OLS, which makes OLS directly available. And finally, from SciPy, import stats, which makes the stats module directly available. If I run this cell by pressing Control and Enter, I can see that some of these functions are actually available in the Variable Explorer. I can verify this has worked by directly calling array 111 to produce the exact same array that I had before when I used either np.array or numpy.array. These are all the same function. In this case, we're just accessing it using a different method. This final method of importing is less common. It is something you only usually use when you want to import a single function from a package. It's not normally used when you want to use many functions from a package. For example, NumPy contains many useful functions, and so it's most common to import NumPy as np and then refer to each of these functions using np.functionName. The advantage of using this method is that it can keep code tidy, especially when importing single functions from a relatively obscure package. In this example, where I've imported OLS, I can now directly use the OLS function, for example, OLS y, x, which would help me run a regression. Don't worry if you're not familiar with OLS. We'll cover this function in particular in the course. The Financial Econometrics core course will cover ordinary least squares regression. This lesson demonstrated how import can be used to add additional functionality to Python. These modules are essential for data analysis. We saw how as can be used with import to shorten the name of an imported module, and in particular to use the canonical set of names. Finally, we saw how from can be used to import a specific function from a module.